Hey guys, welcome to the 3.4 homework. So let's just get started. If you notice in chapter 3.4, it starts off with learning about these basic functions. Okay. Now there's obviously more. There's a whole lot more, but these are the basic algebraic ones that this particular course wants you to be familiar with. So let's go through them one at a time. I guess what I'm going to do is I'm going to just kind of click on one of these and drag it to the correct image. So, okay. So let's start with this one, the square function. Now the square function is called square because it's the equation y equals x squared. And this u here, this parabola, is called the square function, okay? The constant function is a horizontal line because y equals a number, it's just a horizontal line. The reciprocal function, so the reciprocal function is this graph here, 1 over x, it's a type of hyperbola, okay? The cube root function, that looks like an S, so here it is. This is what we call a cube root function. Absolute is a v, so it's one right here. Okay, it bounces off the x-axis. The identity function is the y equals x graph. Okay, it's used to determine if two functions are inverse. So the cube function is the x cubed, x to the third power. It looks like it's kind of like this, but instead of the left half is going down as well. Okay, because negatives stay negative when you cube a number. So the square root function, okay, this is a square root function looks like. If you square root a negative, it doesn't exist. That's why it doesn't have a negative number, or it doesn't have anything to the left. It just has positive numbers. Okay, starting at 0. All right, simple enough. Excellent. And here's a little picture. Good job. All right, next question. It's asking us to do the exact same thing, I guess. Identity. Okay. Cube root. Where's cube root? To S here. Cube function is constant, absolute value, square. There it is, right in front of me. Square root, reciprocal. Okay, so I hope this is making sense. We'll move on to the next. What the heck? Okay, same thing again. I guess it's repeated for like just to make sure you really understood it. Yeah, because some people probably need to do it a couple of times, so it's not bad. Cube function, and then finally cube root. All right, good, excellent, good. So next question. All right. Okay. It's always good to practice identity, so there's nothing wrong with that. Square function, constant, cube root, cube function. Yep, this is all about practice. Practice makes perfect. We all know that. Oh wait, the square function. This is square root. I must have typed, went too fast. See, this is why practice is good. All right, excellent. Okay, so square root function. Like I said, there's nothing wrong with more. Reciprocal, constant, cube function. Where's this one? Identity, cube root. Okay, excellent. You do a couple of practices, you'll be good as you'll be an expert in no time. All right. Okay. Square function, identity. I'm gonna probably remove this for you guys. I don't think you need to do this so many times. Square root function, cube function. Where is it? There. And all right, here we go. Should not. Please no more. Okay. Now, to do this one, it says graph the function. Be sure to label it 3 points. Okay, so we're gonna go ahead and fill out this table. The equation is just y equals x, right? F of x equals x. So that means if I plug in 0 into the x, it's just the answer is 0, right? It doesn't change. So we're just going to go ahead and do it quick. So we're going to get 0. If you plug in 1, well then it's not like you're adding or anything, so it stays 1. If you plug in 2, it stays 2. That's easy enough. Okay. So to graph, I've seen students do it two ways. I think they can click on here and do it here. So they go here, they click on line 2 because it's obviously a line that we're graphing. It's the identity function actually. 0, 0 is this point here. And then 1, 1 is that point here. And then you're done, right? How do you save? I'm not sure how to, let me see, did I just hit check? Okay, good. But before I go further, oh darn it. Well, I'll tell you what. I'm going to move on, but the next question I'm going to show you. Okay, good. It's another graphing one. So let's plug in -1 to the third power. It's still -1. -1 times -1 times -1 is -1. 0 cubed is obviously 0. And 1 cubed is obviously 1. All right. Another way of doing it, instead of clicking here, so you can click obviously on this and do it here. So this is a cube function. So it looks like that. And if you hold on to this and let it, okay, there. It says 4-point cube tool. So it's a cubic tool. So you know it's cubic by clicking there. Then you start plugging in these coordinates, okay? So let's plug in -1 comma -1, which is right here. The next one is 0, 0, which is right there. The next one is 1 comma 1, which is there. It needs one more point. Okay, so let's plug in another point. So let's say x is 2. 2 to the third power, 2 times 2 is 4. 4 times 2, 8. 2 to the third power is 8. So if you plug in x is 2, the answer you're going to get is 8. And it's up here. If you look it up here, you'll see it. So that's 3, 8. This is 2, 8. Perfect. There you go. And now you have the graph. Excellent. 1 over x. This is a reciprocal function. So we know that the reciprocal does not look like b at all or c. It's either a or d. And if you're not sure which is which, well, just imagine. If I plug in 1 into this fraction, 1 over 1, is that a positive answer or a negative? I hope you said positive, because it is positive. So let's look at this one. When you plug in 1, it gave him a -1. That's not correct. That won't match. So D is the answer. Plug in +1, you're going to get 1 over 1, which is +1, etc. Where's my mouse? There it is. All right. Piecewise. This is a very important topic. We'll go over it quickly. So to do a piecewise function, well, first of all, what a piecewise function is taking an equation or taking a situation into pieces of the domain. What that means is, think of the best analogy I can think of is a home, that you're going to paint. Okay, and each room has a different color, suppose. And in fact, there are some colors of paint that you're not going to use at all. That's the idea of a piecewise. So let's suppose you're going to paint, I don't know, the living room white, one of the bedrooms yellow, and the other one green. Nothing's going to get painted blue. Suppose you did nothing blue. So then if I say, okay, I have yellow, where do I go? You're going to say, go to the other room, right? If I say, oh, I have blue, where do I go? You say, oh, blue we're not going to use blue, take it away. You know. Same is true for equations. You can do the same thing with equations. You can say the following. You guys ready? I'm going to copy the equation. So it does say f of x equals, this is not important. What's important is this part. 3x minus 1 if -3x is between -3, including -3, and up to 5. So what does this first line mean? This first line is saying, I want the yellow to be in the corner room or something. Like this is the room and this is, like the color. So if it's, and pretend it said yellow, then yellow goes to this room. That's kind of like the mentality. But this time it's going to be with equations. So I hope I didn't confuse you. But if I say any number between -3 and 5, any number between there, I'm going to plug it into this. I'm going to use that equation to solve. Okay, that's what that means. Now let's go on to the next one. What if instead the number is between 5, not including 5, and 6? So for example, 5.5. Well, any number in this group, I would use this equation. I'll plug it in there. So if I ask you to plug in 6, you're going to use the second equation. If I ask you to plug in 4, you use the first equation. You can only use, here's the catch. The rule is you can only use one equation. You just need to know which one to use. And if you notice, it doesn't have an equation for everything. So if I say I want to plug in 12, well, there is no equation for 12. It doesn't have one. So you would say no solution. Okay? All right, so let's go to the question. A is f of 0. So where can I plug in 0? Into the first or the second equation? We'll call this equation 1 or equation 2. You can't use both, only one. Well, 0 is somewhere in between -3 and 5. So I would use the first equation. So it would be 3 times 0 minus 1. Obviously, 0 minus 1 is -1. I'm looking at the b here. I'm just going to do all of them at once. B seems to be f of 1. So where can I plug in 1? Which equation? Again, you can't use both, but you do notice that 1 is between -3 and 5. So we're going to go ahead and plug it into the first equation. Okay? 3 times 1 minus 5. Oops. Where did I get the 5 from? Okay, I said between -3 and 5. It's a 5 got stuck in my head. Alright, 3 times 1 minus 1. 3 minus, this is the same thing as 3 minus 1, which is 2. How about f of 5? So many 5s. Okay, f of 5. Now here's where some students get a little confused. They say, wait a second, 5 is in both. No, it's not. 5 isn't in the second equation. 5 only exists in the first equation because it says anywhere between -3 to 5, including -3 and including 5. In other words, if I'm going to use 5, I have to still use the first equation, okay? So I'm still going to use that equation. So it's going to look like this, 3 times 5 minus 1. Someone asked me, wait a second, but why can't I use the second equation? Because 5 isn't included in this boundary. If you look at it carefully, it says x has to be bigger than 5, but it doesn't say bigger than or equal to. So it has to be actually bigger. And if you're 5, you're not bigger. You're not bigger yet. Anyhow, 3 times 5 is 15. 15 minus 1 is 14. Okay. The next one, the last one, is f of 6. So where can I use 6? Equation 1 or 2? And I hope you guys agree it's equation 2. Equation 2 would be plugged into the second equation, which would be 6 to the 3rd power minus 5. 6 cubed is 6. You know, I'm not sure. It's 200. Oh, hang on. Let me use my calculator. 6 to the 3rd power is 216, and 216 minus 5 is 211. Okay. Now, I know it's not on this problem, but I want to say, what if I ask you f of 10, for example? Well, does 10 belong to either group? And you say no, that neither group can use 10. It's like you bringing the blue color to the home, but no room is going to use blue. What are you going to do? Take it away. It doesn't work. It doesn't make sense. So you do the same thing. No solution. Okay? Or undefined, or whatever you want to use. Okay? So that's the idea. I'm going to take the drawing now and start typing. So the first answer, let me get rid of this nonsense. There you go. First answer is, oh, darn it. Oh, here it is, less. Whatever. Good enough. -1. Oh, okay. Got to type them separately. 2. 14. And 211. Excellent. Very simple. Next question. So let's just do all of them quickly. So the first one's asking for the domain. I want you to pay attention to this equation. If x does not equal to 0. Let's see the first equation. What in the world is this saying? This is the first one. Use the equation 4x if x is not equal to 0. What does that mean? Well, if you think about it, it literally means every other number except for 0 can be plugged into that equation. So if I ask you to plug in 50, you're going to use 50 into that equation. If I'm going to use -50, you're going to use the same 4x equation. The only time I can't use 4x is when I plug in 0, or when x equals 0. And this is one way of saying it. Excuse me, this is one way of saying when everything except 0. That's how you say it. This is the negative description. The second half of the equation says the answer is 1 if x equals 0. So literally, what if x equals 0? What answer do I give? You say 1. Okay? That's it. They don't even give you an equation. They tell you the answer. So then how do you find the domain? Well, let's think about this. Is there any number I can't use? Or every number fair game? Think of the boundaries here, the restrictions. I can't use 0 for the first equation, but then eventually, when I do want to use 0, I use the second equation. So is there any number that is never used? And you should say no. Every number can be used. Any number. You can plug in a billion, negative a billion, 100, negative 100, 15, negative 15. You can even plug in 0 if you want. Any number goes. The only difference is which equation to use. So then the domain means, again, domain is what kind of numbers are you allowed to use. The domain says any number. Any number, really, if you think about it. So then the domain would be negative infinity to infinity. There you go. Simple as that. All right. Let me see. Do I have to clear this? The intercepts. I will. Nah, I don't need. I have plenty of space. Okay, so To find the intercepts is a little tricky. Okay, the first one I like to do when I have these kind of problems is the y-intercept, but it's the easier one. So the y-intercept is the first one. What does the y-intercept mean? Y-intercept means literally x equals 0. So let's go ahead and just plug it in. Where does 0 go? Into the first equation, to the second equation. And you'll say, oh wait, it goes into the second equation. So then it's okay, so what's the answer? There's nothing to plug in. The answer is automatically 1. It's just y equals 1. You're done. It's because it just tells you 1. So that coordinate 0, 1 is the y-intercept. It's really simple. It's only going to have, remember, you can't have more than one y-intercept. Maybe you don't have any. Maybe you can't, let's suppose this wasn't there. Then it wouldn't have a y-intercept because you can't use 0, right? So this depends on the problem. Now, what about x-intercept? X-intercept means that the y equals 0, that the equation equals 0. Now, this is a little trickier because then that means, okay, but I have two equations. I have technically two pieces. So you have to literally take each piece, 4x, and in this case 1, right? Those are the two little pieces. And you're going to do is you're going to make both of them equal to 0, both of them. Now, before you go any further, what I do, you don't have to do this, but I like to do this. I like to put in a box on top of it the domain. So in this case, this is the domain, right? So x cannot equal to 0, and for the domain here, x equals to 0. I just like to write it's not going to be part of the problem, but we're going to need that information. So now we're going to go ahead and just solve for x. So we're going to divide both sides by 4 to solve for x. X equals to 0. Now here's a question. Before you say, oh, there's my x-intercept, ask yourself, does this solution exist under that restriction? In other words, can I use 0 for this equation? Because that's what it's saying. I have to use 0 for this equation. The answer is no, I can't, because it says right on top I wrote x cannot equal to 0. So therefore, this x-intercept will not function, will not work for this equation. So it doesn't have an x-intercept for the first equation. All right, now I move on to the second equation. Now this one's a little bit more easier to see. This doesn't even have a variable. You can't even solve for x. So then the question is, okay, you can't solve for x. Is this a true statement though? You say, no, of course not. 1 is not equal to 0. So again, there's nothing here. No x-intercept. So here's the interesting thing. The second one had literally no x-intercept. The first one had an x-intercept, but the x-intercept would not exist under this restriction. So it wouldn't work so it didn't have it for that particular piece. So then there's no x-intercept. There's only one y-intercept. I hope there's another example we can do of this, or you can look at the lecture. But it's very confusing, but it's not that bad once you understand it. Okay. Let me clear all this. This may actually help you. So, what would the graph look like? Well, it looks like 4x, which looks kind of like that, right? Looks kind of like that. So they all have the same basic line. But then it says when x is not equal to 0, you can't use that function. So it should have an empty hole when x is 0. So they all have that. Okay, so they all have the first half correct. The second one is if x is 0, y is 1. So that's a y-intercept. This is wrong. It's this one, right? You notice that when x is 0, y is 1. Excuse me. So I want you to see something. I want you to look at this real quick and say, the x-intercept would have been there, but because the restriction says you can't use 0 for this equation, it doesn't have an x-intercept. See how that works? That's why it didn't have any x-intercept. It does have a y-intercept though, and it happens to be that point right there. Okay? So that's the idea. So the answer is B. Okay, let's look at this. Okay, it's asking for the range. To do domain, it would be think of the graph and say, is there any vertical line that wouldn't intercept with the graph? And you say, oh no, every vertical line I draw eventually touches the graph. Are you thinking, well, what about this line here? Well, yeah, eventually, because if you drew this line out, it would come out here, and then eventually this vertical line would touch it, right? So that means the domain is all real numbers. We already mentioned that in part 8. Now for range, is there any horizontal line that wouldn't have intersection? Well, if you look, even this one here has 2 of them, right? You can have 2 intersects, fine. But if you look, the x-axis doesn't have a number because it has an empty circle. So this particular horizontal line is missing a dot. So that means that there's a range restriction. y cannot equal to 0. When y is 0, there's nothing there. So, what's the domain? The domain is everything except for 0, basically. So, how do you write that? You can say the range has at least one isolated value. No, this doesn't make sense. What that means is that y equals 4. Like something, like it means something like this, like 1. Like it has a simple value. That's not true. The range is everything except 0, so it's a range. The range consists exclusively of one or more isolated. It can be this. No, that doesn't make sense. This makes sense. It has no isolated values. It just has the two giant sections. It has this section from negative infinity to 0. And then after that, oh, where's my mouse? There it is. Okay, and 0 to infinity. Okay, so that's your range. And I want you to see one more time. There it is. All right, I want to see one more time what I mean. Any y values under 0, any y values above 0 is fair game. The only y value you can't use is 0. And that's what this is basically saying. Okay? All right, next question. All right, excellent. It's something very similar to what we just did. So let's see. The domain. So let's think of it. I'm not going to write anymore. I'm just going to want you to observe this. If you want to plug a number that's less than 0, you use the first equation. So like negative 10, negative 100. Okay, great. If you want to plug in a number 0 or bigger, use the second equation. Like let's say 100, 0, 15. Great. Here's my question. What's my domain? What kind of numbers am I allowed to use? And you're going to say you're allowed to use any number you want. I hope you said that, because any number to the left of 0 and starting at 0 and to the right, that includes all numbers, right? So we can use any number we want. Obviously, it depends which one we use as to which equation to use, but we still can use any number we want. There's no restriction. So we're going to say all real numbers. Alrighty. All right, intercepts. So I'm going to go ahead and draw this out. So the easiest one I told you before is the y-intercept. That means x equals 0. So then I just simply look at the graph and say, okay, when x equals 0, which equation do I use? Let's see. Do I use the first one? No, because it says less than 0. How about the second one? Yep, x can be 0 for the second one. So the answer would be 0 squared, which is 0. So there you go. So we have 0, 0. Right? That's going to be the y-intercept. How about the x-intercept? How do we do that one? Remember, x-intercept implies that the y equals 0. So we have two different equations. We have two different equations for y. We have 4 plus 4x, excuse me, and then we have x squared. Remember what I told you last time. It's helpful to put the domain of it on top of it. And you can just box it up. It's not going to be important for solving, but it's important. You'll see in a moment why it's important. Now what we're going to do is we're going to solve each of them. I'm going to solve each of them. I'm going to make each equal to 0. I'm going to solve each of them. I'm going to do the first one here. So I'm going to subtract 4. We get 4x equals to negative 4. Divide by 4. We're going to get x equals to negative 1. All right, here's my question. Is this solution, negative 1 for x, does it fit in that domain? And I hope you said yes, because check it out. Negative 1 is less than 0. So it does work. So this is an x-intercept. So what's one x-intercept? Negative 1, 0. That's 1. Excellent. Let's look at the second equation. We're going to solve for x squared. Square root both sides. X equals 0. Does this solution fit in that domain? You'll say, yeah, because 0 is 0, right? 0, it says up here, x can be 0 or bigger, and it's 0. So it does work. So this would be 0, 0. So we have three, well, technically, we only have 2, because this is repeated, but we have 2 different intercepts. We have this one here, and we have that one. Okay, I know it's repeated here, but you guys got the idea. So we're going to go ahead and find my mouse. There it is. I'm going to go ahead and type those 2 intercepts. Don't type it, don't repeat this twice, so mark it wrong. So 0, 0, negative 1, 0. Hope I typed everything right. Okay, good. Now, let's clear the drawing board and let's think about what this picture looks like. Okay, I want you to understand that the graph looks like this, and that's a grid. The graph looks like this. To the left of 0, it's going to be a straight line, 4x plus 4. So 4x plus 4, the y-intercept is up here 4, right? And then the graph would have kind of done that, but since you can't have it on the, up there, it only exists to the left, we're going to circle it and do something like this, okay? So the graph would normally look like that, right? But it only exists to the left of 0. So that's that left side. And then to the right, it's when you plug in 0 to the bottom one, you start at 0, and it's a parabola going up. This is what the graph looks like. It has two pieces, okay? So let's go ahead and let's look at A to me. Yeah, A is the only one that makes sense to what I just drew. So I'm going to hit A. Now I want you to notice the range. Okay, I'm going to clear this and look at the solution for a second here. And I want you to ask yourself, is there any horizontal line that doesn't touch the graph, ever? And you should say no. It always has some type of intersection. Even this one here. It doesn't have one here, but it does have one over here. Everywhere has an intersection. So the range is all real numbers. So I hope you guys see that. This one. It does not have any isolated values. So we're going to put negative infinity to infinity. Alright. Okay. So this, I mean, it looks annoying because you see like decimals and stuff, but it's the same stuff we've been doing. It's actually the easy ones. We're going to plug in 200. Where can I plug in 200? Now look at the domain. According to this, I can't plug in negatives. From 0 to 300, not even including 0, just bigger than 0 up to 300, the answer is just you're going to pay $24.99. I guess it's about money, right? And then if you're going to use more than 300, you plug it in here to figure out the answer. Now here's the question, and I hope you guys understand. If I ask you to plug in, let's say, -5, what will you say? I hope you said doesn't have an answer, so you say no solution. If I ask you to plug in 1,000,000, which one would I use? The second one. If I ask you to plug in 100, what would I use? The first one. So I hope you guys remember how this works. So the first question says plug in 200, right? C of 200. 200 would be plugged into the first one. Now since there's no equation, it's just going to be $24.99. It just tells you what the answer is. In fact, if I use 205, 230, 250, up to 300, the answer is the same, okay? What about 325 though? Now 325, I can't use the first one anymore because it's bigger than 300. So I have to use the second equation. I'm going to go ahead and use my calculator. I'm not going to write it out. I'm going to put 0.2 times 325 minus 35.01. I got $29.99. That's how much I got. Okay? How about 301 exactly? Well, you still can't use the first one because it stops at 300. You have to use the second one. So even though it's really close, we're still going to use 0.2 times 301 minus 35.01. It's 25.19. That's what I got. So let me type that in. Okay. Well, that's easy enough. I don't know why it looks so weird. That little line there showed up out of nowhere. Let me see. Yeah, it's all weird. Oh, darn it. Okay, hang on, guys. Okay, I realized what's happening. I was like, I see a weird line. It's the screen capture thing. So I did this one a second ago, but you probably couldn't read the question. I mean, you have it in your paper, so your computer, so it shouldn't. Okay, so it should be fine. So let me go to the next one, and now you should be able to see it much better. Okay, so now let's get started. It says here, a truck company transports goods between two cities that are 960 miles apart. The company charges for each pound 50 cents per mile for the first 100 miles, 35 cents per mile for the next 300, and 30 cents per mile for the next 400, and no charge for the remaining 160. Okay. Graph the relationship between the cost and, okay, so what would that mean? Out of all of these, I would say the answer looks like it's A, but I'm gonna, actually draw it and produce the solution. So, yeah, you're starting here and you're all the way here, and there's 960 miles between the two places, right? Now it says here, they charge for each pound, and I'm assuming you're not gonna stop and collect more weight. So we're gonna say you just have whatever 100 pounds, doesn't matter. For let's say you have 1 pound, you're gonna be charged 50 cents per mile for the first 100 miles, and obviously it depends how many pounds you have. So if you have 1 pound, then for the first mile it's 50 cents. The second mile is another 50 cents for the first 100 miles. So for the first 100 miles, what you're gonna pay is gonna go up by 50 cents. So it's gonna look something like that until you reach, 100 miles, and then it says afterwards you're gonna pay 35 cents per mile for the next 300 miles. So it's gonna go like to here to 400, and it's gonna be a little bit more shallow. I made it significant, but whatever. And then it says the next is 30 for the next 400. So it's like here's 800, right? It looks like that, and then it's okay. I did a horrible job, but it looks something like that. So let me just click A so you can see it better. So you can see what I'm talking about. Okay. If you have, for the first, this is the x-axis is going to be the miles, right? For the first 50 miles, you're going to pay 50 cents per mile. So and this is the cost, right? So if you don't travel, you pay nothing. You travel 1 mile, 50 cents. 2 miles, $1. 3 miles, $1.50. Eventually, if you travel 100 miles, 100 times 50 cents is $50. You just paid $50. Then you're going to travel the next 300 miles, 35 cents. So let's do a little bit of math. 300 times 0.35 is an extra 105. You're going to pay an extra 105 bucks, but you already have 50, so that's why it's 155. Okay, and then the same thing goes up for this one and then for that one. Now you think, why does this go straight? Because you're not getting any extra charge. You're still going to pay $275 no matter what. So A makes the most sense. Okay, I hope that clarified the answer. The cost of a function of mileage for hauls between 100 and 400 for the first. Okay, so just it wants to know the cost. Okay, so what would it cost for anything? It would cost 0.35 cents per mile plus $50. And you think, why plus 50? Because you're assuming you've already passed 100. Oh, never mind. Let me see it carefully. I take it back. I just realized something. No, yeah, from 100 to 400 miles, it says 50 cents per mile for the first 100. That's $50 eventually, plus 35 cents per mile for the next 300. So, I see. You have to do this. I forgot something important. Because I realized you have to subtract the first 100 miles. So it's going to look like that. That's what I realized. Okay, let me actually explain what's happening. I forgot to do that, so now I get it. So you're going to have 30 cents per mile, but you're not going to put, let's say you travel 200 miles. You're not going to pay 35 cents for 200. You're going to take away the 100 miles you just traveled. That's what this is all about. This is the 100 miles you just traveled. So then let me distribute this. So we're going to get 0.3x minus 0.30, right? Minus 30, sorry, plus 50. So eventually it will become 0.3x plus 20. So that's going to be the answer. Okay. So I completely botched that. I do apologize. So let me go ahead and type that. 0.3x plus 20. Okay. Not the. Did I do my math wrong? Let's see. 0.3 times 100. Okay. 30 is positive 20. That part's correct. 0.3. Oh my god, I'm so dumb. I keep putting 0.3 and it's 0.35. I wish. I'm so silly. I've been using the wrong number to begin with. Why is it not letting me type? Okay, here. it's 0.35, but that means this is also, let me draw here, this is 35, 35, and this is 35, so that's 15. Okay, so that now, just me not reading carefully, happens to the best of us, doesn't it? Okay, so that should work, yeah. Okay, that's what I figured. Okay, sorry for that. Guys, it's been a long day, so let's see. Next one, between 400 and 800 miles. So let's think of this one quickly. All right, now I'm not gonna make the mistake. Where's 400 and 800? First 100, next 300, okay, right there. It's 30 cents. Okay, I'm not gonna screw up this time. And then remember that we just drove at least 400, so it's gonna be x minus 400. And then we're gonna add how much we would have paid had it been, had we gone the first 400, which is 155. And you're thinking, how do I know that? Well, because remember, 50 cents per mile for the first 100 miles is 50 bucks, and then you have 300 miles times 0.35 is $105, and then of course if you add them up together, you just drove 155. You just spent, sorry, $155. Okay. Make sure, yeah, everything makes sense. So now I'm going to distribute this 0.30x minus 120 plus 155. So it's going to be 0.3x plus 35. That's what it would be. So in other words, if x, and you're thinking, why would I have to do all this extra simplification? Because remember, if I'm plugging in, let's say 500, I can't plug in 500. Well, I mean, I can plug it in here, but what I'm really paying is $100 extra, or I'm really paying for the $100 miles, the 100 miles more after 400, because 500 is 100 miles more. But I can't think of it that way. I'm supposed to plug in 500. So that's why when you work it out, this is what it ends up like, okay? So we're going to just go ahead and type that, 0.3x plus 35. And then, okay, let me clear this up. What's this say? The post service of a country charges 39 cents postage for a letter weighing up to 1 ounce. So we know that how much that weighs. So let's actually just type it. If it's up to 1 ounce, you just pay 39 cents. And it says plus 21 cents for each additional ounce up to 5 ounces. Okay, so if it has more, okay, so now you have 39 cents for 1 ounce, right? 0.39 plus you're going to pay an additional 21 cents if it's, this is not hard, this is 0.6, because what I'm doing here is I'm adding 21 cents to the 39 cents. And what if it's more? Then I add 21 more cents there, so that's going to be what, 81? But what if it's more? Then that's going to be $1.02. Let me just put that. What if it's more? Then it's $1.23, right? So that should make, see, hope that makes sense. You just keep adding 21 cents. So what would it look like? It'll look like this. So it's including the endpoint. Yeah, it's gonna look like this. It's gonna just be no matter. Make sure the numbers match, because this number, because they look the same, B and D, but see if you look at D, it says 105, 84, and this has the correct value, so it's B. All right, that's it. That's all there is for the 3.4 homework. I hope you guys understood everything. If you have any more questions, let me know. I'll see you guys soon. Take care.